So this is the 59th video on Newton's laws of motion. So in this video I'll take up two numerical questions which was asked in previous year IIT question paper. Okay. First question I'll discuss which was asked in IIT Jee in 1978, way back in 1978. And another question I'll take up which was asked in Jee Advance 2025, that is this year. So two questions I'll take up in this video. Okay, fine, all right. So I'll write down the question. This was asked in IIT Jee in 1978. Fine. So I'll draw the diagram of the situation. Example 1. Consider the diagram shown below in which all details are given. Consider the diagram in which all details are given. Okay. See, the diagram is this. This is a wedge. This is a wedge having two inclined surfaces. Okay, fine. This inclined face makes an angle of beta with the horizontal, and this inclined face makes an angle of alpha with the horizontal. Here there is a fixed pulley, okay, and here we have a block of mass M2, and here we have a block of mass M1, like this. Fine. There is no friction anywhere. Fine. This is a smooth horizontal surface. This is a smooth horizontal surface. This is the smooth inclined face of the wedge. This is also a smooth inclined face of the wedge. Two blocks of masses M1 and M2 are joined to each other by massless inextensible string. There is no friction between the string and the pulley in contact. This pulley is rigidly fixed to the wedge. Wedge is free to move over this horizontal surface. No friction anywhere, I have already said. This string also I have everything I have said. Now the wedge is made to move at a constant acceleration a with respect to ground towards rightward direction. Question is, find two things we have to find. First, the value of a so that the two blocks stay motionless with respect to the wedge. Stay motionless with respect to the wedge. And second, we have to find the tension in the string. Find the tension in the string. All answers should be in terms of M1, M2, alpha, beta and G. Okay. This is a required question. This was asked in way back in IIT Jee Entrance examination 1978. That is 32 and 20, 57 years before. 57 years old this paper question is. Okay. So this I'll rub it, okay. So now what we have to do in this problem, we'll set up the Newton's second law equation for these two blocks in the frame of wedge. And from those two equations, we'll get the value of A and T. Okay. So first what I'll do, I draw the free body of these two blocks with respect to wedge. This is the wedge, which is denoted by W. This is a block of mass M1 denoted by B1. This is a block of mass M2 which is denoted by B2. Fine. So we draw the free body of these two bodies with respect to wedge. So B2, free body of B2. A real force M2G will act on it in downward direction. The wedge inclined will exert a normal force N2 on the block B2 in this direction, normal to the inclined surface. The string is massless and there is no friction between string and pulley in contact. Tension point, all points of this string is same, T say. Now this string will exert a force T on this block B2 down the incline, T, alright. Now this wedge is a translating non-inertial reference frame because it is accelerating with acceleration A with respect to ground. So as seen from wedge, a pseudo force will act on block B2. Pseudo force will be M2A in leftward direction. Fine. This is the FBD of B2 as seen from wedge. Similarly, what I do, I draw the FBD of B1 with respect to wedge. This is block B1. A real force M1G acts on it in downward direction. Wedge exerts a normal force N1 on the block B1 in this direction, normal to this inclined face. This string exerts a tension T on the block B1 up the incline, and the wedge is a translating NIRF, so pseudo force acts on it, which is simply M1A towards left. M1A towards left, okay? Fine, alright. So these are the two FBDs of these two bodies with respect to the wedge. Now what I do, I write down the Newton's second law equation for each of these blocks with respect to wedge in downward respective inclines. First I do it for M1. What will I say? I write down the Newton's second law equation of B1 with respect to wedge down the incline. So that is what? M1G sin alpha. M1G sin alpha minus T. N1 has no component. Now this pseudo force has a component of the incline, so that is minus M1A cos alpha. Okay, fine. That is equals to M1 times acceleration of block B1 with respect to wedge down the incline. That is simply 0. You should note that since we are writing down the combined equation, we are writing down the Newton's law of motion with respect to wedge. So acceleration here should also be taken of the block B1 with respect to wedge. That is 0, because the block is motionless with respect to the wedge as given in the problem. So right side becomes 0. So if you solve this equation, T becomes what? M1 common, G sin alpha minus what? A cos alpha. This is T. This is the first equation which I have obtained already. I hope it is perfectly clear. Okay, fine. Now what I do, I write down the Newton's second law equation for B2 with respect to wedge down the incline, along this incline, which makes an angle of beta with the horizontal. What will I say? T minus plus M2G sin beta minus M2A cos beta, fine, is equals to M2 into acceleration of block B2 with respect to wedge down the incline, that is 0, because the block B2 is motionless with respect to the wedge. So right side becomes simply 0. So now T becomes what? This right side 0, I shift this to term that side. M2 into A cos beta minus G sin beta. This is therefore the second equation. So from these two equations we can easily solve for T and A to get the required answer. Alright. This one I rub it, okay. So now to find A, first we equate these two T's. In first and second equation T is same, these two should also be same. So from equation 1 and 2 we get M1 into G sin alpha minus A cos alpha minus A cos alpha is equal to M2 into A cos beta minus G sin beta. Alright, bring A to one side. A becomes common. M1 cos alpha plus M2 cos beta is equal to G times, okay, M1 sin alpha plus m2 into sine beta. Okay, so A becomes G times m1 sine alpha plus m2 sine beta upon m1 cos alpha plus m2 cos beta. This is the answer to first part of the question. Alright, we are asked to find A, which has been found in terms of m1, m2, alpha, beta and G. One answer we have obtained. Fine. Now what we have to do, now rub this one. Okay. We also have to determine the value of T. Now, to find the value of T, I substitute this value of A either in first equation or second equation, any one of them, whichever you want. So I substitute this in the first equation. So how much T becomes? T becomes m1 G sin alpha minus A cos alpha. A is this. G times m1 sin alpha plus m2 sin beta. Sin beta into cos alpha upon m1 cos alpha plus m2 cos beta. Okay. Now G is a common term. G goes outside the comes outside the bracket. m1g sin alpha minus m1 sin alpha plus m2 sin beta into cos alpha by m1 cos alpha plus m2 cos beta. Okay. Now multiply this. m1 sin alpha cos alpha m2 sin alpha cos beta minus cos alpha minus m2 sin beta cos alpha. Fine. Alright. Upon this quantity m1 cos alpha plus m2 cos beta. Alright. Now rub this one. Now see, this term goes away. This is common term. M2 comes outside. So T is equal to M1G. M2 comes outside. Sin alpha cos beta minus cos alpha sin beta by M1 cos alpha plus M2 cos beta. Okay. So T becomes M1 M2G. This is nothing but sin A minus B formula, trigonometry. This is nothing but sin of alpha minus beta upon M1 cos alpha plus M2 cos beta, which is therefore the answer to the second part of the question. Fine. So T is equal to M1 M2G sin alpha minus beta by m1 cos alpha plus m2 cos beta. These are the two answers to this question. Okay, so A and T has been determined. I hope it is clear. Alright. This question I have discussed. Okay, one question I have discussed. Now in this video I will take up one more question which was asked in this year's Jee Advanced Physics paper. That is IIT Jee 2025 as set up by IIT Kanpur. So I will take up one question which was asked in this year's Jee Advanced Physics paper. Okay, this are a bit. Okay. So I take up another question on, as I mentioned just now, which was asked in this year's Jee Advanced Physics paper, IIT Jee 2025, okay, Advanced paper, Physics. So I'll write down the question. Okay. Question is this: a projectile is a projectile is a projectile of mass 200 gram, GM meaning gram, is launched in a viscous medium at an angle of 60 degree with the horizontal. Angle of 60 degree with the horizontal. At an angle of 60 degree with the horizontal, with initial speed u. With initial speed u equal to 270 meter per second. Okay. It experiences a viscous drag. It experiences a viscous drag force F equal to minus C times V. Okay. Where V is the velocity of projectile at time t. Velocity of projectile at time t, and C is a constant, which is just equal to 1 by 10 kg per second. Okay, fine. The projectile hits a vertical wall. Projectile hits a vertical wall 2 seconds after projection. After 2 seconds, taking E to be 2.7, find the horizontal distance. Find the horizontal distance of the wall from the projection point. From the point of projection. Okay. This is therefore the required question. Okay. Alright. Write up this one. Okay. So first what I do, I draw the diagram of the situation. See, this is a vertical wall. Here a projectile is thrown with initial speed u at some angle alpha equal to 60 degree. This alpha is equal to 60 degree angle. Initial speed u it is thrown. Value of u is 270 meter per second. This is a fixed vertical wall. Here we have viscous fluid medium, viscous medium. Viscous medium meaning that medium exerts a resistive force on the motion of the body, always opposite to its velocity vector, that is opposite to its direction of motion. So now when it moves in some path, arbitrary path which you don't know. One thing should note it, the path of this shell will no longer be a projectile parabolic path. That is only when only gravitational force acts, no other viscous drag force then. But here viscous drag is also acting, so trajectory will be something else. But we are not asked to find that, okay? Now time 0 it is shown from here. At t equal to say t naught equals say 2 seconds. It hits the wall here 2 seconds later. And we have to find the horizontal distance of wall from the point of projection. Let this distance be equal to say L. Okay, this alpha I rub it now. Alpha I already stated. Okay, I'll write it here. Alpha is 60 degree. Fine. L we have to determine. This is the projection point. Time 0 it has been projected. At some arbitrary instant the projectile has come here. Its coordinates are x comma y. V is the velocity of the projectile at time t, that is tangential to the path. Which is tangential to the path. Alright. Fine. Alright. Is alright? Fine. So now see. And V has a component, horizontal component of Vx, vertical component of Vy. Okay. Now at this instant I draw the FBD of the projectile with respect to ground. So real force mg will act on it. Some resistance force acts on it, F, which is equal to minus Cv. Plus this medium will exert some buoyant force Fb in an upward direction. B for buoyant force. Okay, fine. So what are the forces on this object? I draw it here. mg, buoyant force Fb due to the viscous medium, and resistance force F opposite to its direction of velocity. Okay. Now here we don't have to set up the Newton's laws of motion for the object in vertical direction. It is of no use. Only by considering the x component of motion, the problem can easily be solved. Alright, fine. I'll drop this one. So see, so write down the Newton's law of motion for this body in this direction, x-axis. Okay. So we write m times. I write it what? I write it this way. M times ax. What is this ax? X component of acceleration of block with respect to ground, ax, is equal to net force on the object in positive x direction. When mg and fb, they are in vertical direction, they don't have any component along x-axis. Only this f has a component along x-axis that is opposite to the positive x-axis. So it is minus f into, let us assume the velocity makes an angle theta at some arbitrary instant. This angle is also theta or opposite angles. This becomes minus f cos theta. Alright. Now ax will be written as dvx by dt minus f is equal to cv. Magnitude wise f is just equal to what? That is just cv cos theta. Alright. So this becomes m dvx by dt. C is 1 by 10. V cos theta is nothing but Vx, x component of velocity V of the projectile at time t. Fine, alright. Now m is how much? 200 gram, 0.2 kg, converted to SI units. 0.2 kg, dvx by dt, 0.1 Vx, okay. Now if we divide by this becomes 1 by 2. dvx by dt is equal to minus Vx by 2. That meaning dvx by dt is equal to minus V by 2. Fine. So this means dvx by Vx equals to minus dt by 2. Now integrate this equation on both sides, 0 to t. Initially Vx was what? U cos alpha. And time t it becomes Vx. dvx by Vx is nothing but log Vx. When we insert limits, it becomes log Vx by U cos alpha base e. That is equal to minus t by 2. Alright, fine. Now I rub this one here, okay. So what do we get here? Log U cos alpha becomes 270 cos 60 degree. So from this we see Vx by 270 cos 60 degree is half is equal to e power minus t by 2. This means Vx is equal to 135 e power minus t by 2. This is the x component of velocity of the projectile t seconds after projection. Alright. Now we know that Vx is nothing but derivative of x coordinate of the projectile at time t. That is equal to 135 e power minus t by 2. But we have to determine the value of L as shown in the diagram. Okay. Fine. Now I rub this one. Alright. So now I shift dt that side. So dx equals to 135 e power minus t by 2 into dt. Now integrate both these equations on both sides. It hits the wall after 2 seconds. So limits of t will be 0 to 2. When time is 0, x was 0. It was at origin of the coordinate system. And at time t equal to x coordinate becomes L. When the shell hits this point, at this point x coordinate of the point of the wall is equal to L. That is the horizontal distance between wall and the point of projection. 0 to L. Okay, fine. Now this one integrated and inserting limits we get L. 135 is constant, it goes outside. E power minus t by 2 dt 0 to 2. Fine, alright. Now I rub this one, alright. So it becomes L equal to 135 minus 1 by 2, integrating and inserting limits. It becomes minus 2 by 2 minus e power minus 0. So L becomes minus 270. This becomes e power minus 1 minus 1. 270, 1 minus 1 by e. So this becomes 270 minus 270 by e. 270 minus 270 by 2.7. E is given to 2.7 approximately. So this becomes 270 minus 100. This becomes 170 meter per second is therefore the required answer. Sorry, meter, sorry, not second, sorry. So value of L is just equal to 170 meter and that is therefore the required answer. So horizontal separation between the point of projection and vertical wall is 170 meter and this is therefore the required answer. Alright, fine. I think it is absolutely clear. You go carefully go through it. In case you have some doubt, write it out in the comment box. I'll clarify it. Okay, fine. This example also I have demonstrated. Okay. Next video also I'll take up Newton's laws of motion. Some additional questions I'll take up. Okay. They will not be of IIT previous year IIT paper, but I'll be setting my own questions. Okay. So this I close it here. Fine. Alright.